Good morning, my dear students. Welcome to Tenali pathshala. As you know, I have started important questions chapter wise from chemistry, first PU, midterm as well as annual examination purpose. So already I have made a video on some basic concept of chemistry, structure of atom, organic basic principles and techniques, these four chapters. Now I am making fifth chapter, that is states of matter. So if you have not seen those videos, the link is given in the description. First go through that videos, then come to this one. Yes guys, let us start states of matter. First we will talk about one mark question. Mention the value of gas constant R in SI unit. R is gas constant whose value in SI unit they are asking. As you already know, 8.314 joule per Kelvin per mole. This is the correct value for R in SI unit. Write the van der Waals equation for n moles of real gas, not ideal gas. They are asking for real gas. For ideal gas, PV is equal to nRT. For real gas, P plus AN square divided by V square into bracket V minus NB is equal to nRT. This is for real gas. Who given this? Van der Waals. State Boyle's law. Remember guys, out of Boyle's law, Charles' law, Avogadro's law and Gay-Lussac's law, definitely one law they will ask for statement and mathematical expression. Okay, so let us discuss Boyle's law. At constant temperature, the volume of the given mass of gas is inversely proportional to pressure. Means at constant temperature, volume is inversely proportional to pressure. Who told this one? Boyle's. At constant temperature, volume of the given mass of a gas is inversely proportional to pressure. So this is a Boyle's law. State Charles' law. See guys, this question was asked in 2013, 2017, 2019 annual exam question paper. So at constant pressure here, at constant pressure, volume of the given mass of a gas is directly proportional to absolute temperature. Means pressure remains constant, volume is directly proportional to temperature. That is called Charles' law. If temperature is constant, volume is inversely proportional to pressure. That is called Boyle's law. Remember, yes. Write van der Waals equation for 1 mole of real gas. You know van der Waals equation? Sorry, I have written ideal gas equation. You have to write that van der Waals equation. You don't know that. So, as third question we have discussed, no? Van der Waals equation. That you have to write in that place. You have to write in place of n. You have to write 1. And you will get the answer. This is ideal gas. I have written ideal gas. This is wrong guys. So just correct it. Mention the type of intermolecular attraction that exists between non-polar molecules and HCl molecules. They are asking. Type of intermolecular attraction. So when non-polar molecule is there, that interaction is called London forces or dispersion forces. And HCl molecule. In HCl molecule, H plus Cl minus both the ions are present. Hence, you will get dipole-dipole forces. Name the type of intermolecular force broken in the process of evaporation of water. So, when water is converted into vapor, so which type of intermolecular forces are broken? Hydrogen bonds. So, when hydrogen bonds are broken, water liquid converted into vapor form. What is mean by absolute zero? The lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called absolute zero. Its value is 273.15 degrees Celsius. What will be the volume of 10 cm cube of oxygen gas at 273.15 degrees Celsius? Volume of 10 cm cube of oxygen they are asking. See, it is always zero because an absolute zero temperature is 273.15 degrees Celsius. So at absolute zero temperature, volume of 10 cm cube of oxygen is zero. Remember. What is an ideal gas? Which obey all the gas laws like Charles' law, Boyle's law and Avogadro's law. The gas which obeys Boyle's law, Charles' law, and Avogadro's law is called ideal gas. Gay-Lussac's law. At constant volume, pressure of a given mass of a gas is directly proportional to absolute temperature. So pressure is directly proportional to temperature at constant volume. So this was given by Gay-Lussac. What is aqueous tension? Pressure exerted by saturated water vapor. Pressure exerted by saturated water vapor is called aqueous tension. Between CO and CO2, which diffuses faster? CO diffuses faster because it's lower molar mass compared to CO2, because CO is having lower molar mass as compared to CO2, hence CO will diffuse first. Write the expression for combined gas equation. P1 V1 divided by T1 is equal to P2 V2 divided by T2. This is the equation for combined gas. P1 V1 divided by T1 is equal to P2 V2 divided by T2. What is the value of critical temperature of CO2? And its value is constant, guys, 30.98 degrees Celsius. Give the mathematical form of Boyle's law. What is Boyle's law? At constant temperature, pressure is inversely proportional to volume. So how to write inversely proportional? P is inversely proportional to volume. That is what P, proportionality sign 1 by V, indicates inversely proportional to volume at constant temperature. This was given by Boyle's law. Give mathematical form of Charles' law. At constant pressure, volume is directly proportional to temperature. That you have to write. Volume is directly proportional to temperature at constant pressure. Give reason. Liquid drops are spherical in shape. Very important, guys. See. Because they tend to acquire minimum surface area to reduce surface tension. They wanted to reduce the surface tension, hence they wanted to acquire minimum surface area. Therefore, they are spherical in shape. Spherical have minimum surface area. Spherical shape. Already you studied. So here completes 1 mark questions. We'll talk about 2 marks. State Boyle's law and write the relationship between density and molar mass of the gas. So what is Boyle's law told here? At constant temperature, pressure is inversely proportional to volume. Right. And very importantly, the relation between density and molar mass. So many times they have asked, guys. Molar mass, M is equal to dRT divided by P, where D is density, M is molecular weight, T is temperature, P is pressure. Mention 2 conditions at which real gas approach ideal behavior. So at what condition real gas is converted into ideal gas, they are asking. At higher temperature and lower pressure. Remember, low pressure and high temperature, real gas converted to ideal behavior. So that means they can obey all the laws also. Following? Yes. Why do real gas deviate from ideal behavior? Why they are actually deviating from ideal behavior, they are asking. Because 2 reasons. They have intermolecular force of attraction. Actually in real gas there is an intermolecular force of attraction, therefore they deviate from the ideal behavior. Gas molecule have considerable volume. Gas molecule have considerable volume, hence this is also a reason to deviate a real gas from the ideal behavior. What is viscosity? It is opposition to flow of liquid. Correct. So many definitions you can quote here. See guys, I have written here properly. The resistance possessed by, that is opposition only, resistance possessed by liquid for its flow, which arises due to internal friction between layers of the fluid, is called viscosity. And SI unit of viscosity is Pascal second, PAS, Pascal second, SI unit. Define surface tension, give its SI unit. If we imagine a line of unit length means 1 meter length. If we imagine a line of unit length on the surface of the liquid, the force acting perpendicular 90 degree perpendicular to it is called surface tension, and SI unit of surface tension is Newton per meter. Critical temperature of CO2 and methane are 31.1 degrees Celsius and minus 81.9 degrees Celsius respectively. Which one of these has stronger intermolecular force and why? CO2, because one who has higher critical temperature, that itself is having stronger intermolecular force of attraction. See, CO2, because gas with higher critical temperature will have higher intermolecular forces, hence liquefied first and hence having stronger intermolecular force. What is meant by normal boiling point and standard boiling point? What is the difference between these two? I am asking. See guys, normal boiling point, temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure, is called normal boiling point. What is standard boiling point? And normal boiling point of water is 100 degrees Celsius. What is standard boiling point? Temperature at which vapor pressure of the liquid becomes equal to 1 bar. So there vapor pressure of the liquid becomes equal to atmospheric pressure, that is called normal boiling point. But temperature at which vapor pressure of the liquid becomes equal to 1 bar, then it is called standard boiling point. Normal boiling point of water is 100 degree, standard boiling point of water is 99.6 degrees Celsius. I hope you followed guys. Explain with an example London forces. The forces of attraction, the force of attraction between two temporary dipoles is known as London force. Explain with an example dipole-induced dipole interaction between the molecule of compound. A non-polar molecule may be polarized by presence of polar molecule near it, thereby making it an induced dipole. So example here is noble gas get polarized in presence of polar molecule. Mention two conditions at which real gas approach ideal behavior. So already we have discussed this one. When real gas approach ideal behavior, when temperature is high, pressure is low. Remember, low pressure and high temperature leads to real gases to approach ideal behavior. Remember, very important. Explain with an example dipole-dipole interaction between the molecules. See, dipole-dipole interaction is possible only in polar molecules. So it is interaction between polar molecules. So example is between HCl molecule. Write the expression for compressibility factor Z for 1 mole of gas. What happens to the compressibility factor Z for CO2 at very high temperature at ordinary temperature? See, first we will write the expression. Compressibility factor Z is given by Z is equal to PV divided by nRT. First question is over. Again, what is they are asking? What happens to the compressibility factor Z for CO2 at very high temperature? See, for ideal gas, Z is equal to 1. So Z is greater than 1 under high pressure. Remember. Now, 5 mark question guys. Write any 4 postulates of kinetic theory of gases. 3 mark. 3 postulates, 3 mark. Write van der Waals equation for 1 mole of real gas. That means they have given 4 mark for postulates, 1 mark for van der Waals equation. Let us discuss. This is very important question guys. So many times this question is repeated. Very, very important. Postulates of kinetic theory of gases. Definitely they will ask. Postulate of kinetic theory of gas. First one. Gases are made up of large number of small particles called molecules. Volume occupied by gas molecule is negligible as compared to total volume of gas. There is no loss of kinetic energy during the collision. In average kinetic energy of the gas molecule is directly proportional to absolute temperature. So these are very important 4 postulates of kinetic theory of gases. So many times this question is repeated. Write van der Waals equation, not ideal gas equation. They are asking van der Waals equation for real gas. P plus An square divided by V square into bracket V minus Nb is equal to nRT. So they are asking for 1 mole, put in place of n you put 1. So an square is there. In place of n you put 1. So 1 square means 1 only. So here also nb is there. In place of n you put 1. Here also nrt is there. In place of n you put 1. So what you are getting totally? P plus a divided by v square, v minus b is equal to rt. This is the correct answer. Right. Any 4 postulates of kinetic theory of gases. Again, the first question is same only, guys. Only second question they have made different. See, so many times I told you the same question is repeated in so many years. Calculate the temperature of 6 moles of gas occupying 4 dm cube at 2 bar pressure. R is also given to you, 0.0825 liter atmosphere per Kelvin per mole. This is the unit they have given to you. Now tell me, what is the given data in the question? 6 moles of means n value is given. 4 dm cube v value is given. 2 bar p value is given. They are asking temperature. Which, no, see here, n is given, v is given, p is given. They are asking T. Which formula you are using? Ideal gas equation. So PV is equal to nRT. We want T. You take nR that side. So T keep as it is. Take nR that side. nR is multiplicative. When you take that side, it becomes dividend. So T is equal to PV divided by nR. Put the value of P. P is 2, V is 4 divided by n is 6, R is given in the question 0.0825. So when you calculate it, you will get 16.16 Kelvin. So you will get answer in the Kelvin. I hope you followed, guys. Derive ideal gas equation from gas laws. This is also very important question, guys. So many times this question is repeated. See, from the states of matter in annual examination, you will get either kinetic postulates of kinetic theory of gas or derivation of ideal gas equation. Definitely out of 2 anyone you will get, 100% guarantee. So how to derive it? Only three laws you have to write. From combining all 3 laws, you will get one expression, PV is equal to nRT. So that we have to derive it. See, first you tell me, at constant temperature and number of moles n, V is directly proportional to 1 by P. So 1 by P means what? Inversely proportional. So if you call it as a directly proportional, then read it as a 1 by P. If you call it as a inversely proportional, then read it as a P. At constant T and n is number of moles. V is inversely proportional to P means it is a Boyle's law. At constant pressure and number of moles n, V is directly proportional to T. T means temperature. This was given by Charles' law. At constant P and T, V is directly proportional to n, number of moles. This was given by Avogadro's law. So combining all these things, carefully see, V is inversely proportional to P, V is directly proportional to T, V is directly proportional to N. By combining all these things, what you will get? V is directly proportional to N and T divided by inversely proportional to P. That you will get. V is directly proportional to NT divided by P. So if you want to remove proportionality sign, you have to write one constant. So I am going to write that constant as a capital R. V is equal to RNT divided by P. What is R here? R is a proportionality constant called as universal gas constant. We got this, but what we want? Ideal gas equation. Take this P that side. So what you will get? PV is equal to nRT. P is pressure, V is volume, N is number of moles, R is universal gas constant, T is temperature. So this is a derivation of ideal gas equation. Simple question, guys. 3 mark they will give. Write any 4 postulates. Again, first question is same. I'm not going to repeat again. Write any 3 difference between ideal gas and real gas. See, guys, this is also very important. Ideal gas and real gas difference. So first we'll talk about ideal gas. Ideal gas obey all gas laws at all temperature and pressure. But real gas obey all gas laws only at high temperature and low pressure. I told you, no, real gas behave as ideal gas when the temperature is high and pressure is low. But ideal gas will obey all the gas laws in all temperature. Either it is higher or lower, whatever temperature or whatever pressure may be, ideal gas will obey all the gas laws. But real gas will obey only at high temperature and low pressure. Ideal gas has no definite value. Real gas has definite value. In ideal gas, there is no intermolecular attraction force. But in real gas, there is a presence of intermolecular attraction force. Ideal gas obey PV is equal to nRT. real gas obey P plus AN square divided by V square into V minus NB is equal to nRT. So these are the four differences between ideal gas and real gas. I hope you followed, guys. What is effect of increase in temperature on vapor pressure, surface tension, viscosity? So what is vapor pressure? Increase in temperature. If you increase the temperature, what happens to vapor pressure? Vapor pressure will increase. If you increase the temperature, what happens to surface tension? Surface tension will decrease. If you increase the temperature, what happens to viscosity? Viscosity decreases. Last question. Define the following terms: Boyle temperature, critical volume, critical pressure. We'll start one by one. What is Boyle temperature? Temperature at which a real gas obeys ideal gas laws over an appreciable range of pressure is called a Boyle temperature. Now, critical temperature. The temperature above which gas cannot be liquefied by applying pressure is called a critical temperature. Let's talk about critical volume. Volume of 1 mole of gas at critical temperature is called a critical volume. What is critical pressure? Pressure required to liquefy the gas at critical temperature is called as critical pressure. I hope you followed, guys. So this is regarding important question and fixed question which are going to be asked from states of matter. You just practice some problems also. So if you want problems also, I will make another video. If you want, comment below, guys, and please share the video among your friends. So many people just seeing and leaving like that only. Please share the video among your friends so that every student can get a benefit of it. Thanks for watching, guys. Thank you. So stay tuned for next lesson. So which lesson you want, please comment below, guys. Either you want mathematics or chemistry, and which chapter you want, comment below. On that basis I will make another video. Yes, thanks for watching. Thank you.